there are reasons why it's a lot of work, and I'm going to kind of walk you through some of that. But AWP does require a reasonable maturity in planning, and in particularly in critical path method scheduling. It takes a highly collaborative design and construction effort. So it can't be a confrontational relationship between design and construction, design and owner, design and CM, construction and CM, because it's a collaborative effort. If we're going to embrace full AWP and get to the full maturity level, you have to adhere to the guidelines and procedures. We have to have that complete alignment between planning, design, and construction. And then there has to be contractual support. So that's what sort of steps in and starts moving you over the hump, where it goes into the contracts. Early stage implementation, usually alignment of the design is the hardest part. And this first stage is the riskiest part, the hardest one to implement, because you have to get that alignment right. And that can be a bit of a fight, a bit of a chase a lot of times. And it does sort of disrupt some of the existing processes. So some of the sort of traditional way that people operate. The planning is more detailed, and that's a necessary part. And the planning is performed much earlier. So in order to step into even this early stage, you cannot accept an answer from someone that says, well, we can't plan any details because we haven't got the design finished and we don't really know what we're going to build. But that's foolish because, unless it's the first time you've ever built a project, most people are stepping into a project where they have the experience. And I think they generally will find that they built something before similar. They often have a good detailed estimate. All that sets us up to be able to do good scheduling. But it really does align very well with good CPM practice. So the good news is, if you are fairly mature in your CPM scheduling, then you're going to find that the path I'm walking you on is going to be fairly straightforward. And it may take no change, it may take minor change. So, and if you look at the three stages, at the effort required compared to the positive impact, to the return on that. This is a nice little chart that CII put together. And, the biggest effort is in constraint removal. So this is identifying those places that will limit our ability to perform this, things that would be impediments to doing our planning or to getting the work done, or implements at the work phase. And that takes some effort to get past that. However, if you get that done, if you put in that effort, there's a very high positive impact from that. And the other issues are similar. If the first stage is achieved, then we really get in the second stage a lot of good performance improvements, mostly because a lot more of the disciplines have adopted AWP. Stakeholders are more comfortable with it. And good CPM practice is the underpinning of all the levels. So it really supports that. If we look at stage 2, the impact versus effort again, the backlog is very high effort. Backlog in the AWP world is all about identifying places where you can implement an installation work package. So the more places that you have to be able to put people to work, that's your backlog. And the more places you have, the more flexible you are, and the ability to keep people moving and be productive is a lot higher. And so it takes some effort to, really identify places you can work and things and get that into the schedule, make sure it's reasonable and appropriate. But then the impact from that can be pretty high as well. And then the transformation stage is when the business has adopted it pretty much entirely. And this is where the real success happens at AWP. And if you talk to someone and they say they use AWP all the time, it works great, they're in this stage. They're in this transformation stage. They're not stepping into it. But what I'm going to show you today, I think, will put you on the path to make it a lot easier for you to move along and move up through the maturity path. But at this stage, all the other projects are starting to use it. We get good quality improvements. The planning process is pretty well established, and teams adopted it, so it's still fully aligned with good practice. Here, the effort sort of moves into online document control and procurement management. And so those are the efforts you have to, really put in, but then the positive impact is really good when that happens. Okay, so this is sort of the meat of what I want to talk about today, is how can our CPM scheduling evolve into advanced work packaging? Because it does require reasonable maturity in planning and scheduling. What we find is that the typical early stage planning is often not detailed enough to support AWP. And so that's the first stumbling block. If you try to, start implementing AWP and you really haven't done that early detailed planning, you don't have enough information to make it work. The scheduler has to understand the sequencing needs, and the team needs to work with that scheduler, whoever's handling that. But we need a good construction team that provides input, takes ownership of the schedule, helps work through this. It takes a fully collaborative planning and scheduling effort. But even on complex projects, still good CPM scheduling will open the door and let us work. So what we do in our planning session, we start with the delivery of long lead time equipment or erection sequences in a planning session. Now, you might say this is good CPM scheduling, and I would agree with that. This really is, and it's really what opened the door for me to start moving into AWP when I first read about it and started getting exposed to it, was because I'd already worked really hard to get my CPM scheduling talents and our process cleaned up and useful and valuable. And it is, because the better job you do planning the project, the more likely it is the project is going to work to that plan. So if we talk about long lead time equipment, the first thing we do is identify when the equipment is available. When can it be delivered? And generally, that's the earliest it can be delivered. Then the next step is, we run a backwards pass from each piece of equipment through the foundation engineering for that equipment. And so we want to pick up everything that has to be done to get us from foundation to the equipment and going backwards. So if there's winter concrete placement, cure time, all that needs to go in the schedule and be planned. If it's inside the building, so maybe you have to get some of the building built first. But we work backwards from that piece of equipment one at a time. As we're putting this together, we may find that there's building close in around those same areas, and that may drive us into another path of construction, a path of sequencing. Those access paths can often drive sequencing. It can be something like elevator shaft drilling or modular construction installation. And those can all be things that help drive how we're going to plan this. So that backwards pass has to identify all the appropriate sequencing that's needed, and it lets us really make the transition. So in this case, we have a date for gas turbine. We have a foundation that has to be placed by a certain date. We had to prep for the foundation, so we had to form rebar, set up in beds, blockouts, whatever we had, and get that work done. Before that, we had to have rebar shop drawings and procurement to be ready to start installing rebar. And before that, we had the whole foundation design. So this sequence drives our ability to set that gas turbine at the earliest possible time. If we don't do these things in this order, then we're not going to be ready to do this. You notice the first thing in this order is the engineering drawings. So if the engineer has, nobody's directing them, nobody's working with the engineering or the architects on the different designs, this may not be something they're working on, right? And so that's why we have to do this early planning. We have to establish, in order to meet this milestone, all this needs to happen. There's a certain time frame to that. That means that there's a date by which we need to have engineering drawings complete. And these will be the engineering work packages. That's the basic concept, fairly simple. And then, then we're going to continue setting the equipment on foundations and go forward, and then look at all the major equipment structures. And if the project's not driven by equipment deliveries, like it would be in a piece of equipment, it'll be something else that drives a milestone. So, it might be when you really need to have the building erected in order to make the rest of your work happen by the time frame. Or there may be some outside constraint. You need to have a road built before some other projects started or something like that. But this is really just CPM scheduling, right? This is good CPM scheduling, good detailed scheduling planning, starting early on before we have drawings, and really setting it up and identifying what needs to happen. So to me, this is what we would do in a good CPM scheduling development session. So a planning session, a scheduled development session, and we do it all the time. We have a similar process for erection sequences. The field installation is going to dictate those sequences. So let's say the last sequence of steel needs to be erected on this date. And we figure that out, and then we work backwards and say, okay, working backwards, there's an overlap because we could start this, we could start this west end while the center section has been, it's up, it's been guy wired off, they're welding bridging, they're tying things together, but they have enough done to let us move forward to the next area. And the same thing is true of the center. We go back to the east end. And so there's again an overlap in how that works. So here we just established the string of activities to get all the structural steel erected. What is it going to take to erect? And we have to start at the east end, move to the center, and then move to the west end. So that's the sequence we established. We're doing this unrelated to the drawings, to when the drawings are coming out, unrelated to approvals, unrelated to fabrication. We're doing this planning early on. And the only constraint here is something related to when we need this done. So that may be, we need 5 months after that to finish off the work. It may be there's something else that drives it, but something is driving this need to be done by a certain date. And we work back through the sequences of fabrication. Then we go from that point and we look at the earliest fabrication we needed to do is the east end. We have to have that steel delivered in order to erect that. And we walk through the various paths again, but we're now looking at delivery. So here's the delivery path. We need to deliver on this date on the east end. Once that's delivered, we move to the center, move to the west end, and each of these has to feed the erection sequence. And so we're sort of working backwards. Now we do it again and look at fabrication. And as we work back through the fabrication, east end fabrication will go first because that's our first sequence we need on the structural steel. And we get that done and we know when that can happen. Then we have the center sequence, the actual fabrication, and then we have the west end fabrication. These drive everything forward. And if we've done a good job of this sequencing, then we're probably okay with this, but we need to be sure we knew the order. And as you can see right here, if the structural engineer provided us, center section of steel, and that came out first and, had the ability to get it delivered and to erect it, well, it won't help us because we needed to have the east end erected first. And I've seen this happen. I've come in, I do a lot of troubleshooting, I always have. And, I got involved with a project in the Middle East where they didn't do this. And the first set of precast panels that came out, they were not able to erect because they needed another sequence done first. And and what happens if you're doing precast? I did a precast garage recently. In our early planning session, we met with the precaster and we talked to them about the garage. And we said, we're doing a little 4-story parking garage. Are you going to build 4-story tall precast panels and erect those so they'll go in one at a time and complete the building as you go? Or are you going to erect 1-story precast panels, maybe that are wider, and you'll set those one at a time around the building? And once they're all set, it'll free you up to do the next level and the next level. That's an important piece of information to understand. And that's what helps drive an understanding of how this needs to happen. And so this precast in the Middle East, apparently didn't have that conversation. So, they were at a kilter, which meant, precast material sat on the job for months without being able to be paid for it. It had to get bonded. You had to worry about the weather, and nothing could start erecting. So important to make this happen. And then once we have this established, we know when we need to start fabrication. Well, that will dictate when we need to finish the structural steel design. East end first, center second, west end third. And so this whole effort, this early planning effort, yields for us when we need the structural engineers, the engineering design to happen, when we need them to start and finish, depending on their schedule, and where we need them to start and finish. And so, absent going through this planning effort, you might be leaving it up to the engineering firm as to where they start. And so maybe they have 3 engineers working on it. Maybe they have, people doing different things. Maybe one engineer designs their bar joists and deck, and another engineer designs their structural steel and beams and columns. And so maybe they had, somebody was available and they start the bar joist first, and we can't take the bar joist until late in the game. So it's really important. It's a fairly simple concept. And if you're a good CPM scheduling, PM or scheduler, you recognize this and you kind of are already doing this. But in AWP, we formalize this with the process a little more. And it becomes vital that, we actually hit these sequences and we know when they're going to happen. So this starts the beginning of the construction work package. And that actually includes the engineering work package. So this starts the work package where we're now putting together an entire package, and I'll show you how that works here in a second. The construction work package spans from design to procurement. And so, that's how you set up and handle even the procurement. The engineering work packages are a deliverable that comes out of engineering design and then feeds back in to somewhere else. And these are contractual packages. And then that moves us forward. And then eventually the EWP, rolls into the IWP. And the construction work packages feed contract information and other things to the installation work packages and maybe resources and that type of thing. And so this is kind of an overview, but this is the way it works. And lots of contractors might be strong on the work phase planning with the installation guidelines, but they aren't really getting in and doing this early planning for the schedule to make that happen. So CPM schedule sequencing, if you're doing a good job, we are doing this early interactive planning. Once the sequencing is complete, the engineering or architectural design is sequenced. And that lets us adjust early work packages as well. So once we've worked out all these sequences, then once we've worked those out, we can start determining what's the earliest work package that can be released and how do we get that released, how do we make that work.